Hold on, let me get a calculator.
Yeah,
Be right back. Don't push play yet, or record.
all right, I'm pausing.
Oh, I better get a laser pointer. So there's three things to remember when you're doing trigonometry, is that you have sine, cosine, tangent. You have that either memorized or written down somewhere. There's a relationship between the O and the H, and the A and the H, and the O and the A. And then you have to know on your calculator, for first function, you're doing a side, and for second function, you're doing an angle. So let's take a look at that and see what we're talking about on the calculator before we get started. Take a look at your calculator, and it says sine, cosine, tangent. Do you see that?
Yes.
Yep.
Where it's white, sine, cosine, tangent, where it's white, that's first function. Then right above sine is something in yellow. That's second function. Do you see that?
That's
Yes.
the inverse,
All
right?
Huh?
That's the inverse, right?
That is the inverse. Thank you.
Yep.
Who said that? Donovan?
Yes.
That was very good, Donovan. Smart kid. He must have taken math 101 or something.
103.
So second function is the inverse, and that's sine to the -1, cosine to the -1, and tangent to the -1. Now, the Egyptians knew all this way before, it was like 5,000 years ago. They did this, and they could figure out their pyramids and their angles of their pyramids all almost to the 10th degree. I mean, they basically had exact science, and then nobody could ever figure out how they did it, but they knew for sure the aliens were involved. Now, that's just not true, because what happened is that they found out evidence later that they were using a wheel, and the wheel had a mark on it, and it was a cubits, and that was their measurement. You remember in the Bible it says 20 cubits, the Noah's Ark was 20 cubits by 40 cubits or whatever it was. I made that up, but yeah, it was some cubits. What they did is they took the wheel and they put a mark on it, and then they took it. You ever seen a surveyor, how he does that? He's got like a wheel with a stick on it, and then as they roll it around, the wheel just keeps going around and around and around. So as the mark would go, that'd be 1 cubit, and then it'd be another cubit, and then that had to do with pi. The reason that pi was involved because it was a circle, and nobody knew how they knew all this. How they know pi without alien help and stuff? Well, it's just that they stumbled on this just by practical application, so they could make their pyramids exactly correct. So let's learn from them. Okay, so what we got? They didn't have calculators, by the way, and so they had to figure all this out by hand. So what we're going to do is show you something very clear. Now I'm going to draw you a picture of a triangle. Now my drawing is not totally accurate as far as two triangles being exactly the same, but what I'm going to do, guys, is don't I sound like the guy that's at the Piala Fair trying to sell you a mop?
Yeah.
So these triangles are identical. Now, I apologize, they're not identical, but they're supposed to be identical. So if this is the case, then this is an H. Always, H is the opposite of a 90 degree. By the way, this whole scheme of trig will not work unless you have a right triangle. If you're using an isosceles triangle or an obtuse triangle, it will not work. You need a right triangle for this to work. However, I can make a right triangle out of any triangle. I'll show you how to do that. So if I have a triangle like this,
Right down the middle.
then I just go right down the middle, and now I got two right triangles, and I just solve it I just multiply it by 2. I actually can solve the whole problem just by 2 triangles. So anyhow, that's H. So tell me then, what's the opposite of a 90 degree? Repeat back to me. What's the opposite? An H, right? H stands for hypotenuse, right?
Right.
Do we agree?
Yes.
All right. So there's a hypotenuse. Now, in one case, this is going to be my angle, so I'm going to tick it, and the other one is this angle. This is very important. Remember, I told Brian and all you guys, make sure you draw it out. Don't come to me and you got all kinds of calculations and do I multiply this times this and do I divide by this? I don't know. What you need to do is draw it out and you have a visualization of what you're doing. So make sure, and when you do chapter 14, you draw every single problem out. Make yourself a triangle, and then go H, and then go A and O, and then tick your angle. Now, where does O and A belong? Well, A is the opposite, so the opposite of this is O. You see that?
Yeah.
And the opposite of this is O. Guess what? These triangles are identical. Yet this is O, and that's O. So then what's the adjacent to this angle? That's an A, right? You guys follow me so far?
Yep.
This is as hard as it gets. I mean, it doesn't get any harder. So the opposite is an O. So what's the adjacent? A. Now look what happened. This O, the length of this O is the same as the length of this A, yet the length of this O is the same as the length of that A. The only difference is I'm talking about this angle in this case. In this case, I'm talking about this angle. The other thing you need to know is both this angle and that angle add up to be 180 degrees. Or 90, excuse me. 180 degrees is all three, but 90. So this angle plus that angle is 90. Do you agree? Do you understand that? That's just simple, basic geometry. Now, geometry turns into trig once I understand that hypotenuse is always the opposite of a 90 degree. O is the opposite of the angle I'm talking about, and A is the adjacent to the angle I'm talking about. And then I can use this relationship right here to solve any problem. And if I want to find a side, I use first function. And if I want to find an angle, I use second function. Just as easy as that. That's how easy it is. Let's prove to ourselves we know what we're talking about. You guys remember the Renaissance period? Were you around?
Sure.
Yeah.
Okay, so it was Michelangelo and Leonardo da Vinci, right? So they were drawing all kinds of pictures, and everybody was amazed by their quality of work.